Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, inspired and refreshed. And if you find my videos important to your studies, please don't forget to subscribe. By the method of least work, determine the support reactions at A. E is constant. So here we go. Let's select the redundant forces at A to be our redundant forces. This is indeterminate to the third degree. So let's have the sectioning first. So take note of the different moment of inertias per segment of the beam, and for the last, which is sloping member, the length is square root of 3 square plus 8 square. So the slope would be, this is 3x over square root of 73, the hypotenuse. So 3x over square root of 73, while this one is 8x square root of 73. So first, partial of u with respect to AH, the first redundant, equals 0, and it is equal to the integral of quantity 0 to 8 of AH times x plus MA. Differential derivative is x dx over 2 because the moment of inertia is 2. For the next segment, plus AH times 8, then plus AV times x plus MA minus 15x squared. Derivative is 8 dx. So we don't need to divide because the moment of inertia is 1. And for the last segment, integral from 0 to square root of 73 of EH times quantity 8 minus 8x over square root of 73 plus AV times 6 plus 3x over square root of 73 plus MA, then plus 50 times 8x over square root of 73 minus 30 times 6 times quantity 3 plus 3x over square root of 73. Then the partial derivative of this moment equation with respect to h is 8 minus 8x over square root of 73. The whole integral divided by 1.5 because the moment of inertia is 1.5i. So integrating the first part, the value is 256 AH over 3 plus 16 MA. This one is equal to 384 AH plus 144 AV plus 48 MA minus 8640. For this next integral, we have 121.515 AH plus 159.488 AV plus 22.784 MA minus 13,366.62. Combining like terms, setting up the first equation. So 590.848 AH plus 303.488 AV plus 86.784 MA equals 22,006.62. By the way, some of these frames will be discussed in slope deflection equations, and in there we will draw also the shear moment diagram as well as the elastic curve. And here you'll find the solution perhaps shorter than the slope deflection equations and even shorter than the moment distribution method. So for the next redundant force, which is AV, we copy the moment equation except for the differential in the second factor. So we have integral of AHX plus MA over 2 times 0, then plus integral 0 to 6 AH8 plus AVX plus MA minus 15x squared. The differential with respect to AV is x dx. Then copy the third integral 0 to square root of 73 of quantity AH times 8 minus 8x over square root of 73 plus AV times quantity 6 plus 3x over square root of 73 plus MA plus 50 times quantity 8x over square root of 73 minus 30 times 6 times quantity 3 plus 3x over square root of 73 times quantity 6 plus 3x over square root of 73 over dx over 1.5. So integrating the first term, so this is of course 0. Then this one is 144 AH plus 72 AV plus 18 MA minus 4860. For this last integral, which is lengthy, 159.488 AH plus 324.672 AV plus 42.72 MA minus 26,258.57. Combining like terms and then setting up the second equation, we have 303.488 AH plus 396.672 AV plus 60.72 MA equals 31,118.57. Call that equation 2. Then lastly, that partial derivative of u with respect to the last redundant force, which is MA, equals 0, equals integral 0 to 8 AHX plus MA, and we replace this by dx only, then over 2, plus integral 0 to 6 of quantity AH times 8 plus AVX plus MA minus 15x squared. Then this is dx only. Then plus integral 0 to square root of 73 of AH times quantity 8 minus 8x over square root of 73 plus AV quantity 6 plus 3x over square root of 73 plus MA plus 50 times 8x over square root of 73 minus 30 times 6 times quantity 3 plus 3x over square root of 73 dx over 1.5. So for the first integral, 16 AH plus 4 MA. For the second integral, 48 AH plus 18 AV plus 6 MA minus 1080. And for the third, 22.784 AH plus 42.72 AV plus 5.65696 MA minus 3,474.56. Combining like terms, setting up the third equation, 86.784 AH plus 60.72 AV plus 15.696 MA equals 4554.56. Call that equation 3. Solving these three equations simultaneously, we obtained AH equals negative 4.646 kilonewtons, AV equals 82.518 kilonewtons, and MA equals negative 3.363 kilonewton meter. So that means AH is rightward, 4.646, AV is upward, 82.518 kilonewtons, and MA is positive counterclockwise, 3.363 kilonewton meter. So that's it for this problem.